Hey guys, welcome to this new video. In this video here, we're going to see how we can do image classification on the CIFAR-10 dataset with Ultralytics and ULV8. So for ULV8, we can use it for both instant segmentation, object detection, RNA bounding boxes, post-estimation, but also classification. So I'm going to show you how we can go in and train our own image classification models with ULV8 in just a few minutes. So let's just jump straight into the Ultralytics documentation. Let's go in and take a look at the different datasets. So all these datasets, if you go inside the datasets, tab up here at the top, we'll be able to see all the datasets that you can pull directly. You just need to specify the data YAML path, and then it's going to basically just extract it, also download it to your computer. But you can also use your own dataset. You just need the exact same structure for the training set and also the test set. So if you go inside this CIFAR-10 dataset, we can read about the key features. So we have 60,000 images divided into 10 classes. We're going to see some example images in just a second. So these images here, they're colored and they're 32 by 32 pixels. So this is a very low image resolution, but often when we're talking about image classification, we don't really need that much pixels to be able to go in and classify what is this image, what is the class of the image, compared to when we're doing object detection, instant segmentation, and so on. So here we can see that we just have some standard classes: airplanes, cars, birds, cats, a bunch of different animals. If you go a bit further down, we can see we have 50,000 images in our training set and 10,000 in our test set. I'm going to show you how we can use it inside a Google Colab notebook in just a second and train it on a GPU, on a free GPU in Google Colab in just a few minutes with these single lines of code. Here we can see some sample images. They are very low resolution, as you can see. It kind of like looks like Minecraft images, but we have all of these here, and the model will be able to extract and also classify each individual class with very high accuracy. So you can use this on your own custom data set. You just need to have them in the correct folder format. We have videos covering all of that, also how you can use the Ultralytics hub. So you don't need to write any code at all. You can just take your data set, connect it to the hub, hit train. You can see all the live metrics, take the model, use it in your own applications and projects. So right now, let's just go in and see how we can set up a Google Colab notebook from scratch. So I'm just going to copy paste this, but you can also use the command line interface. You can probably just take that because you can also use that in a Google Colab notebook. I'm just going to reconnect to the runtime. First of all, make sure that you have changed the runtime to a T4 GPU. So this is a free GPU on a Google Colab notebook. First of all, here we can just type in NVIDIA SMI just to verify that we have a GPU and take a look at what type of GPU and the resources available. We have 15 gigabytes of RAM and we have the Tesla T4 GPU. Then we need to pip install Ultralytics in here, and we're pretty much good to go. That's the only thing that we need to do. There we go. And if we have this explanation mark in front of it, we're going to use it as a command line, and you can also just execute Python code directly in these code cells. So right now, let's just go down, call YOLO detect, and then we have train CIFAR10. We can specify the classification model that we want to use. We have the nano, small, medium, and so on. Just as if we're doing object detection, we specify the number of epochs. Let's just go for 30 right now, just to save some time on that. We can also specify the image size, so it's 32 by 32. You can even go in and specify the batch size here if you want to play around with that, either like 8, 16, and so on. It will depend on how much RAM you have on your GPU when you're training. So right now it's just pip installing Ultralytics. After that, we can run this command and it will start all the training automatically. Pull the dataset from the Ultralytics dataset registry. And again, if you have your own dataset, just make sure that you have it in the correct format. There we go. It is now installed and we can run this command. So we'll just pull all the information, download the model automatically, download the dataset automatically, and we can take a look at the dataset structure. So this is the structure that you will need if you create your own custom dataset. But it's basically just taking your images, placing it in folders, and then the folder names will be the classes of your dataset that you want to detect or classify with your model. So there we go, we can see it pulls all the information. We have unzipped the dataset successfully inside our content directory. So if you go inside our datasets, we have CIFAR10 and it has extracted it. Then we have our test set and our training set. If we just go inside the test set, we'll then have a class here, or basically like a folder with each individual class. And then inside of these, we just have all the images representing a dog. So all our dog images will be inside this folder. Then you can take an arbitrary number of classes that you want to classify and also an arbitrary number of images that you can throw into it here. This is the whole format that you need, and you can train your own custom ULV8 classification models with Ultralytics. So we can see that it has already started training epoch 1 out of 30. We can see the classification score and so on, but let's just let it train here. Let's take a look at the training results, how we can do validation of the model, and also how to run inference once we have a trained model. So I just trained it here for 5 epochs to save some time, and we can see that it pretty much just increases over a number of epochs, where here after epoch 4 to 5, it pretty much just increases with 0.02. So it will take a pretty long time to go in and train the whole dataset for like 20-30 epochs. It takes around like 2 minutes to train for a single epoch because it has to run through 60,000 images. So we can see that after 20 minutes of training, we already have some pretty good results of almost 0.72 here in the top 1 accuracy. So it's pretty much just classifying the correct label for the images 72% of the time, and also top 5 accuracies, it is pretty much close to 100. So it gets the correct classes, at least when we're talking about the top 5. All the information, everything from the training and also the models will be stored over in the runs directory. So we have our classify, train 2, then we have our weight files. You can just right click it here, download the best model or the last epoch, so the model for last epoch. You can use it in your own applications and projects. Basically just go in, create a new instance of the model, and you're good to go. You can either run it from the command line or in Python. Go ahead and take a look at the results. So we both have the results PNG. So let's open that up. We also have our confusion matrix. So here we can see our losses, they're decreasing. Accuracies are still increasing. So they should be converging over time when you have trained it for long enough. Let's go ahead and take a look at the confusion matrix here. So ideally we should have all the classes here in diagonal, which means that we classifies it perfectly because we have the true labels down here on the x-axis, and on the y-axis we have our predicted labels. Generally it looks pretty good. We can see it has some problems here where it predicts it is a frog where it is some of the other animals. So this is like probably like one of the largest errors that we have in the model for now. We can also go and take a look at some of the validation predictions. So here we can see an example. Let me just zoom a bit in. So it's pretty hard to see because they're only 32 by 32. And then we have these colored classes depending on what class it has predicted. So just close all of this here and let's go ahead and take a look at the evaluation. So right now we can run evaluation on our test set. And here we can basically see that we just end up with the same results as the last epoch. You can also run validation automatically, but again, usually just go over, take a look at the validation badges. Are those results good enough? Then you can use it in your own applications and projects. So once we want to do that, we can go inside the Ultralytics again. Let's take the Python example. Let's just grab this part. There we go. I've copied it. We can now throw it in and use the Python. So now let's go over, copy the path to the model that we have trained. So this is the model that we have custom trained on this specific CIFAR-10 dataset. Instead of calling train now, we can just throw in the predict method. So model.predict, or we can just throw it directly into the model as well. And then we extract the results. You can basically just extract all the results using in your own application and projects, depending on the classifications that you get from the image. Here we need to specify the source. So let's go inside our data set. So CIFAR-10, we have our test images. Let's just go in and take a look at an airplane, for example. Let's just grab the first image in our test set with an airplane. We just need to pass it in here. There we go. We can specify that we want to save the results. So we set that equal to true. You can also specify if you want to show the results and so on. So there's a bunch of different arguments that you can go in and check from the Ultralytics documentation. You can also specify the confidence score and so on if you want to take that into account. But right now, let's just call model.predict. We're good to go. We should get the results out, and it will also store the results over in our runs directory. So now we can see that it has been passing this image through. The highest confidence score is an airplane with 60% confidence score. And here we can see that it has the ship, automobile, truck. So it's still in that class range, or at least those types of classes that we have. It's not really predicting it as an animal. So now we can see we have our runs, classify, predict. So this is this folder. We can open up the image and we should be able to see that this is indeed an airplane. It might be very small here, but you can see the image and it says airplane 0 on top of that. So both the class and also the confidence scores. All that information can be extracted directly from the results variable. So if we just print that, so print results. So here we see all the information that we get from this result variable, depending on if we're doing object detection, classification, post estimation, and so on. So if we just take the results, we can see that we have our original image, our names as well for the classes. So we can go and extract the names. So we can just call dot names. And the other one that we're interested in is the props here down here at the bottom. So right now, let's just print this part. There we go. Now we're printing the classes, and we can do the exact same thing with our props. There we go. Let's try to print those. So right now we can see all the information from our classification results. So we have our data. It's just a tensor. So this is the raw output from the model. And then we have our shape here. So we have a shape of 10 because we have 10 classes where we have a confidence score for each of them. Here we see of tops 1. So that is the 0th index. So if we go up and index that in this dictionary, we get an airplane. So this is how you can extract the results, indexes in this dictionary up here at the top. So that's pretty much good to go. And inside here, if you want to extract the actual results, I can just copy it further down here, and we can just have another dot top 1. Let's call this, and then we get the index. Then we can just create a variable, so top 1 equal to this one, and then you can go inside the classes up here at the top, so names, and this is just like a traditional dictionary. There we go, and then we can just go inside here and index it directly with our top 1, and we can print that result out, and this is how you extract all of the information. So now we get the airplane, and you can also go in and extract the confidence scores directly from our top 1 conf. So instead of just top 1, you just type in conf, and it's going to give you the confidence score. You can play around with that. So right now it's just a tensor. So if you want to extract the value, you can just call item from PyTorch. So this is how you can extract the value from a tensor. There you go. Now we have the confidence score, the airplane, and this is how you can extract the results. Use it in your own applications and projects to trigger different types of systems. Or if you just want to throw in a bunch of images and put them into folders, classify them, or like have some kind of like feedback loop running. You can both do it for the top 1, but also top 5. Might be some cases where you want to get top 5. So it could be like top 1, 2, 3. What are the probabilities of those classes? So this is how you can do it. You can just take another image. Let's just go in and grab one more. So we have the CIFAR-10. Let's try one of the other classes. So let's go in with this horse instead. Let's just grab an arbitrary image, copy the path. Just swap it out here. That's the only thing that you have to do. Also, if you run this in your own application and project, this is the only thing that you need to change. So now we just get a new folder over to the left. So we have our classify. We should get a predict 2. There we go. And now we can go in and check the image. So again, it pretty much just detects it as a horse, but also the second class was a deer, which kind of like makes sense. Now we can go down, just extract the names again, the probabilities, run all of these blocks of code. We get 25% confidence that this is a horse. So this is not as confident as the other one. And here we have the deer with 20% confidence. So it's always good and relevant to extract the top 5, take a look at it and verify the results in that way. But this is how you can use classification with Ultralytics on a dataset from Ultralytics. It will download automatically, but you can use it in the exact same way with your own custom dataset. You just need to make sure that it is in the correct format with these individual folders and classes. So thanks a lot for watching this video here, guys. I hope you learned a ton. Definitely go in and check it out. It's only a few minutes that you need to set everything up and you're good to go. Use it in your own applications and projects. Check it out, and then I'll just see you guys in one of the upcoming videos. Until then, happy training.